All right, so with roots and radical expressions, very first thing we're going to do, and we've worked on this a little bit, but we're going to kind of hit it really hard for this part we're looking at here for the next week or so. When we're talking about radicals, there's your square roots. We've done a lot with square roots. We'll do some more with third, fourth, fifth roots, that kind of thing. But basically, whatever number that they put out here, that is the index. Sometimes just for calling it a different name, we'll call it the root. So whether it's the index or the root, that's what we're looking for on the outside here. Whatever number you put on the inside or expression or whatever that thing is, it's here. That's called the radicand. And the big thing that we'll do is that, again, we have to talk about the root or the index and the radicand, so we've got to be able to know what it is when we're talking about the different things that's there. So, okay. That will change depending on, it changed from second to third to fourth to fifth, that kind of thing. So, okay, so for this one, we're going to call this an nth root radical. And again, that's kind of going back to Emma's question over here with this one. That's going to change the base. This, and again, n is just a variable. So this could be square root, could be third root, could be fourth root, could be fifth root, could be any root number that we want outside there that we're going to do. All right, and the big thing we're going to do with this one, when we've got all the roots and all this thing that's set up, here's what we're kind of looking at. You want to simplify the radicand as much as possible. And for the first little bit of time we're going through this one, it's going to work out. It's going to work out perfectly. We're going to simplify this one, and there really is not going to be anything left. Now, eventually, we'll move to the point where it won't be that way. But in this first few sets of notes we're going through here, everything's going to work out kind of perfectly. So you want to simplify the radicand as much as possible, and then we're going to write it in factored form. Okay. In a perfect world, in an ideal situation when we go through this thing, you want to have that whatever root you're working with on the outside here, you want some number, some base that you have to also be to the nth power, because if you do that, the nth root and the nth power would cancel out. And if you can get it that way, your answer would equal B. Okay, and again, we've done a little bit with radicals when we took, especially when we were simplifying square roots and we had to go back and do the factor trees with it and do some stuff with it. We've already done that a little bit. This one's just going to take it a little bit different direction because everything from now is not going to be square roots all the time. It could be square roots, could be third roots, could be fourth roots, could be fifth roots. That again, for this one, you want your root here and your index here. You want these two things to basically cancel each other out to leave you with whatever number you've got left over. All right, now one little catch to this one little thing you've got to be careful of. And it's more of just a little detail that we'll worry about in the first section when we go through this one. After we get through the first section, we're not going to worry about this because we're going to just assume at some point in time we're going to say, all right, we're not going to worry about this anymore. We're just going to assume that we know what it's going to be. But here's one little detail you've got to be careful of in the first section. If your index or your root is even, you must put an absolute value symbol index around your answer. Okay, and it's just one of those little things that, again, we're going to do that in the first section. Sometimes it's not going to be okay, but then sometimes there's going to be an answer, and you're going to put the answer in. You're going to, I know that's correct, and then you're going to get the answer, and you're going to go, oh, wait, that's the same thing I have, but then there's absolute value symbols there. So it's just one little detail that we've got to get through. So here's the extra part of the detail on this one is you've got to determine if you need the absolute values. Okay, and a lot of times we'll go through this one and people are like, all right, so what are we looking for in this case? So basically for this one, here's what you're looking for. You need the absolute value when you have x to an odd power. Because a lot of times people are like, well, what are we looking for? Well, this is basically what you're looking for. Okay. And again, there's basically, when we're going through these, there's going to be a couple of different answers, a couple of different problems that we're going to have. And for this problem, for these particular problems that we're going to, the sample questions here, we're going to do these. You don't have to worry about any absolute values. This is going to be, because the difference on this one is this one's going to ask you for list all roots. So in this case, they're saying, all right, don't worry about the absolute value part of this one. We're just going to go ahead and do what we need to do for these. Okay, if you have square root of 25, okay, what number times itself will give us 25? We got 5, right? What other number could it be? Could be negative 5, right? Because if you do a negative times a negative, that would also be a positive. So in this case, if it says list all the roots, they're saying, all right, you're going to tell me it can be positive or it could be a negative 5. Because again, if you're thinking back to, and you don't have to write this, but if we're rewriting it like this, where that you've got this root to match up with this power. Again, you don't have to write this. Just kind of watch that. If there is not a power or an index here, it's always understood that's the square root. So that's understood to be 2. So it's the square root of 5 squared. But it also could be that's the square root of negative 5 squared. So that way, these would cancel to get us 5. These would cancel to get us negative 5. So that's technically what we're doing. But with square roots, we've done it enough that it's like, okay, it's not a big deal because we know what the numbers are, as we're going through these. All right, so for this one, let's go with the 4th root of 16. Okay, so if we go through our powers of this, 4th root is 2. But what happens if we do a negative times a negative times a negative times a negative? Still Still positive, right? So in this case, you'd also have to put the plus or minus for that one also. All right, so here's basically on this one. If it says list all the roots, if it's an even index out here, you've got to put the plus or minus for an even index. Okay, now that's if it says list all the roots, because in a little bit we're going to change it to where we're going to just list the root, and then we're looking for one answer. This one's saying list all roots, so they're basically saying, all right, there could be more than one correct answer for this one. In a little bit, it's going to be list the root, the solution. So then we're looking for one answer, and we don't have to worry about the whole plus minus. Okay, now one more of those with the listing all the roots here. Because what if that number was the third root of 8? All right, so if the fourth root of 16 is 2, because that's 2 to the fourth power, basically, 8 would be 2 to the third power. So that would just be 2. Now, somebody may be saying, well, we put a plus or minus here. What happens if you do negative 2 to the third power? That'd be negative 8, right? So not a positive 8. So in that case, if it's third root, fifth root, those kind of things, there's only one number that's going to be the answer. If it's a positive number, the answer is going to be positive. If that had been the third root of negative 8, then the answer is negative. Because the only way you can get 8 is to do 2 to the third, where this is positive, where if that's a negative 8, that would be negative 2 to the third. Okay, and that way your third roots are going to cancel here. Your third roots will cancel there. All right, so on some of the questions where it's going to list all the roots, if it's an even index, you want to put the plus or minus. If it's an odd index, if the number is positive here, it's going to be positive here. If the number is negative here, it's going to be negative there. Just because it's your, I guess, your power principle of how many times you're multiplying positives or negatives, and it's going to make, kind of a little bit change on those. All right, so here's the part. So that's listing all the roots. Here's where we're going to change it just a little bit. Okay, if it asks you to simplify, this is where they're looking for one answer. And if it asks you in this case, you might have to use your absolute value. So simplify is looking for one answer. Yeah, this is one answer. Absolute value symbols might be needed. I'm going to write that out because it's... Okay. So if it just says simplify, realize that absolute value could be needed. Doesn't necessarily have to be, but might be needed in your answer that you're going through. Okay.
Absolute value is now AV.
Yeah, AV for absolute value. All right, so we're going to start with some that's pretty easy, and then we'll work our way up to some that's a little bit more thought-invoking. All right, fifth root of 0.
Wait, what? Is this like example 1 that
Yeah, I just thought we'd go A, B, C, D this time instead of example 1, example 2.
Okay, I'm
Okay.
just making sure.
All right. Yep. All right, fifth root of 0. How many times do we have to multiply 0 to get 0?
0?
Just how many times we need it, right? Because we do 0 times 0 times 0 times 0. It doesn't really matter. And again, what you can think about, and again, this is just the thinking part here. It's the fifth root of 0 to the fifth power. So those are canceled. So that's 0. And you may be saying, well, we know that anyway. We can multiply 0 a bunch of times. Okay, but we've got to get the thought process going that we're trying to match up this power on the inside with this index on the outside. If we can do that, then it makes the canceling, a little bit easier there. All right, fifth root of 32.
Wait.
Okay.
Oh, wait, no. Hold on. You think? Yeah.
Go through your powers of 2. That's the fifth root of 2 to the fifth. Okay, and again, those will cancel. Answer's 2. All right, if we do fifth root of negative 32. All right, we know that 2 to the fifth is 32. If it's negative 2 to the fifth, if I can write it. Because again, if we do a negative number 5 times, we know the answer would be a negative. So negative 32 would be negative 2 to the fifth root. Your 5s would cancel out. So in that case, the answer would be negative 2. Yes. All right, so same thing with, let's say it was negative 1. If it's the fifth root of negative 1, negative 1 to the fifth power would also still be negative 1. So again, your 5s would cancel. So answer is just negative 1. Square root of 4. All right, now here's where the absolute value part of it kind of comes in for this one. We know that square root of 4 is 2. Okay, but here's kind of the thought process on this one. Because it could be, because again, we know that if it's square root of 4, that technically this is the second root. So, it could be 2 squared. It also could be negative 2 squared. Okay, so if we did it this way, this could be 2. It also could be negative 2. And here's where they kind of put these things together to say, all right, when do you need the absolute values? Because if it's 2 or negative 2, they're saying, all right, this is a case where we want to go ahead and do the absolute value. So if we got these two things, then we know the answer would just be 2. All right, so if you've got that option of whether it could be positive, because if we kind of go back to listing all the roots back here, it could be positive or negative, and they're saying, all right, if we're going to simplify, we only want one answer. So if we've got 2 answers, the only way to get it down to one answer is to take the absolute value of that number. Okay, now again, it's just one of those little things that we're getting through here, but eventually we'll get to the point where, we won't have to worry about it quite so much this thing. All right, so this one, if you look at F is one of those where it's a little tricky because we've got the 6th root of negative 4 to the 6th power. All right, these two things would cancel. That would make it negative 4. Okay, because these would cancel.
Yeah.
All right.
Oh, wait.
And technically it's negative 4 to the first power because there basically would be 1 left when we get through this thing. So this would be one of those numbers where if they gave it to you like this, you would then really have to do the absolute value of it to make it 4. Because they kind of look at it as, all right, what happens if we did negative 4? Because what if we did the inside part at first? What if we did negative 4 to the 6th power and then took the 6th root of it? You get 4 back as your answer. So depending on the order of operations you go with it, if you did this part of it first and then took the 6th root of it, your answer would be 4. Where if you just did these two straight away, the answer would be negative 4. So they kind of say, all right, what answer is it going to be? I know that's a little odd, but again, just realize we got to get through the first section, and then we'll get rid of that option once we get to the second section.
So does the homework ask for absolute value?
If needed. Okay, so let's say if you had the square root of negative 5 squared. Oh, sorry, should have been G. My bad. Sorry about that. Forgot my alphabet for a minute. All right. Again, technically that is square root. Yeah, so we got 2 there. Technically, these would cancel out. Well, because if there's not, so one thing that if you go through these, if there is not an index here, yeah, it's always understood to be 2. Always. So if there's no number for the index of the root, it's always understood to be square root. Always. Yep. Okay, so technically these would cancel out and leave you with -5, but it's back to the same situation. Yeah, we got to do the absolute value of it. So technically the answer would be 5. All right, and some people were asking about imaginary numbers. For just a little bit, just hold off on the imaginary numbers for a little bit. So if one of the questions that you have in the homework happens to do something like this, after G, there's H, right? Yeah. Okay. Well, let's say you have the square root of -49. Now, previously, we said that number would be imaginary. Right now, we're still looking for real answers. So for this one, we're going to say that this thing would be no solution. We will do some imaginary stuff later, but for now, just assume we're looking for real answers. So if they happen to throw in a negative square root, just say, all right, that's going to be no solution. And remember, that's different than, fifth root of a negative number. That one you can actually get a solution, but if it's a square root of a negative number or a fourth root of a negative number, there's no way you can get a real answer off that one. All right, if you happen to have a fraction, square root of 36 over square root of 121. Yeah, you can think about that as like 2 separate numbers. It's like square root of 36, which would be 6, square root of 121, which would be 11. So they can think about that as being just 6 over 11. So it's just 0.3. All right, so again, make sure we got the negatives okay. Third root of -27. Okay, so for K, third root of -27. All right, and again, if you break it down, that would be -3 to the third power. And again, your third root, third power, third index, those 2 things would cancel out, just get you -3. But again, as long as this is an odd index, it's kind of nice when this is an odd index, you don't have to worry about absolute values. So the answer is just -3.
Wait, so we can just use the calculator?
Yep. Fourth root of 625. Yeah, 625 is 5 to the fourth. Your powers of 4 cancel. Now, in that case, it's 5. Do we need an absolute value to put around that? Because 5 is already 5, so we're good to go. Now, technically, it could be 5 or -5. But again, if we're only looking for one answer, we need the answer to be positive, so then we'll make it that way. Okay, so now I think where it's really going to see more of it is when we do the variables. So let me show you this part with variables, and this should be kind of the last thing when we go through some of these with variables, so you can kind of see. Now, variable wise, I actually like doing variables better just because of how it's set up. To simplify variables, you're going to divide the powers of the radicand. Again, radicand is what's on the inside. So we're going to divide what's on the inside of each variable by the index. So you're dividing the inside by the outside. So take the inside powers, divide it by the outside root or the outside index. Which, again, technically is still what we were doing back here. Because when we were doing the previous problems, that if you took, this one, if it was -2 to the fifth power, you would do 5 divided by 5. So that would leave you with -2 to the first power. So that's technically what we're doing back here. It's just sometimes the numbers get a little jumped up. With the variables, it's a lot easier to see that that's what we're doing. Yes. So inside power by the outside index or the outside root. So we're going to do the third root of x to the 12th and y to the 18th. Okay, so all we're going to do for x is we're going to take 12 and divide it by 3. We're going to take y and divide it by 3. 12 divided by 3 is 4. 18 divided by 3 is 6. And there you go. Yeah. And for this first section that we go through, everything will work out nice and even. There won't be any remainders, no leftovers. Everything's going to work out nice and perfect. Even with the numbers back here, everything is going to come out perfectly as you go through all the numbers of what's here. All right, let's do the square root of x to the 6th. All right, again, square root technically means that's supposed to be a 2 for the index. So this becomes 6 divided by 2, which is x to the 3rd. Yeah, so if there is no index or root here, it's always understood to be a 2 for a second root. Because if you read it, you would just say square root, just assume that's a 2 for the index there. All right, now here's where you have to be careful. Here's where we're going back to this rule that we're talking about back here. If the index or the root is even, which is what we've got here, right? Index is 2. You must put an absolute value symbol around your answer if the answer basically has x to an odd power. Because what happens if we were to, because again, we're going back to evaluating, is that what happens if we plugged in a -2 for that, for x? Answer would be -8, right? And they're kind of getting you to the point where if we're simplifying, we want the answer to be there. So if we plug in a 2 or a -2, it's going to give us 2 different answers. So basically on a problem like this one, here's what we have to do. We're going to do that. Because we started off with an even index, the answer is an odd power. So if you start with an even index and the answer is an odd power, you're going to have to put absolute value around that number. Depends on the number you plug in. If you take the absolute value symbols off and you plug in -2, the answer would be -8. Or if you plug in +2, the answer would be +8. So what they're getting you to is that they want the answers to always be positive. So if you could plug a number in and possibly get a negative answer from a positive number, they want you to use absolute values. So it's a little confusing. The thought process is there, but eventually we're going to get to the point where we're not going to worry about it. So, all right. So for example 3, let's do the square root of 81 x to the 4th. All right, now in this case, we've got two different numbers. We've got a number and we've got a variable. So you can kind of think about breaking these up, that it's the square root of 81 and it's the square root of x to the fourth. So if you've got a number and a variable expression together, you can separate them into two pieces. Okay, what is the square root of 81? That's 9, right? Now, do we need absolute value? Now, technically, again, if we think about it technically, it's the square 81 would be 9 squared, correct? Because you got an index of 2. The 2's would cancel to get 9. Do you need an absolute value around 9? Because what's the absolute value of 9? It's 9, so we don't need it. Okay. All right. If we square root x to the fourth, because again, we're doing square root over here, that's 4 divided by 2. So that's x squared. All right, and again, we have to think technically, because if this is an odd answer, we would need it, but it's even, so we don't. Because what happens if you square a negative number? It becomes positive, right? So in that case, we don't need absolute value because no matter what number we plug in here, it's always going to be positive. So in that case, you don't have to have the absolute values. This one, you could get a negative answer because it's x to an odd power. So if you did a negative, it would come out that way. This one, you'll never get a odd answer because no matter what you do with x squared, it's always going to wind up being a positive. Okay, but again, if you kind of think about this one, this is the only scenario where you're going to need absolute values. If you start with an even index and you have x to an odd power, you want to put absolute value symbols there.
Maybe a stupid question. But what if you have an exponent that's negative and it has to be written like absolute?
All right, so let's do the fifth root of 32, x to the 10th and y to the 40th. All right, good news on this one is, notice it's an odd index. We don't have to worry about absolute value. So as soon as you see this is an odd index, you go, all right, we don't have to worry about the whole absolute value thing. All right, if we check the fifth root of 32, we've already done that, correct? That would be 2. So we can do the fifth root of 32. We can take the x and have it be 10 divided by 5. We can take the y and have it be 40 divided by 5. Okay, again, fifth root of 32, we know is 2. For the x, 10 divided by 5 is 2. 40 divided by 5 is 8. And again, no absolute values needed because it's an odd index to start with. So that's kind of the good news is if you get an odd index, you can go, oh, okay, I can relax. I don't have to worry about the absolute values. If it's an even index, that's when your radar's got to go up that there might be something weird or goofy with it. Okay, last one. Let's go fourth root of x to the 12th, y to the 16th. All right, so that is x to the 12 divided by 4, y to the 16 divided by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. Okay. And if that's your answer, Math Excel is going to count that wrong because you started with an even index, right? This one has an odd power, which means if you plug in a negative number here, this would give you a negative answer. If you plug in a negative number here, it's going to be a positive answer. So this part of it's okay. So then technically, we've got to put absolute values around just the x to the third part.